Hi, welcome to Newline's Building React Native Apps for macOS. My name is Oscar, I'm the creator of the course. I'm a software engineer from Bolivia, but I live in Germany. I have a lot of experience with React Native, and last year when Microsoft released the macOS version of React Native, I decided to create my own application. During this process, I had to develop a lot of new and novel techniques, and together with Newline, we decided it would be a good idea to release a class about it. Now, this class is divided into 5 modules. We will start with the very basic JavaScript and React Native topics and slowly transition into more advanced functionality. Now, because we have 2 types of developers taking the course, we have to maintain certain balance between the topics. But still, at the end of the course, we should have a very functional and truly native desktop experience. Looking forward to it and wish you the best. It can be hard to grasp what will be the end result of our class. Therefore, I thought it would be easier for me just to show you the final state of our application. Our application is a status bar app. It runs on the background and it's presented to the user here in the menu bar at the top right corner. If I click on the item, it's gonna open itself and it's gonna show me a list of my favorite books. So here I can add even more titles. I can click on the titles and this is going to take me to a Google search where I can see at the news. It also has some extra features. For example, it can launch itself at login whenever I start my computer. It can also deattach itself and create a new window where I can use my app as any other windowed app. It also has support for notifications, which are presented to the user. And it also supports drag and drop for, let's say, supporting adding images to my favorite books. These and other features we will explore during the course. Now, before we start, it's a good idea to discuss the pros and the cons of using React Native. There are many good things, but like everything in life, there's no magic bullet. So among the good things is React Native is cross-platform. You will be able to reuse most of your code across all the platforms that you're aiming for. You also have hot reloading. If you ever develop a native application, you know it's time consuming. With the JavaScript stack, most of the time you only need to save your files and your changes will be replicated. You will also be able to save costs, not only because the framework itself is quite fast and you will be able to reuse a lot of the code, but you will also be able to find developers for the web stack. React Native also has a very large community nowadays, and there are libraries for most of the use cases, so you don't have to develop all the functionality yourself. And lastly, we do have performance as a good point. Even though React Native runs on the JavaScript stack, the apps are quite performant by default. Not always, but you don't have to do that much work to achieve a very performant app. Now, there's also some compromises. First of all is the experience. Since you will be running inside of React Native, you may not have access to all the native elements that you would wish. We also have performance as a downside. Even though some of the elements of your application might run fast by default, if you try to achieve certain things like background uploads or downloads, your application might suffer a little bit of a slowdown. Now, those are the pure React Native points, but macOS has some peculiarities about it, let's just say. So among the good things is you will be able to reuse most of the mobile code, but at the same time you also want to provide a desktop experience. So sometimes you will require to write specific code for the desktop. Among the good things is you won't have to learn all the Objective-C APIs, and you also won't have to learn Objective-C, which is most of the time very cumbersome. And one of the downside is the port is quite new. Support is quite good and a lot of the holes are being patched, but every once in a while you might find some missing functionality that you will have to work around on your own. Hi, I'll just create a bare bones app for our course. I'm just gonna follow the instructions in the lesson. So I have it open here and I have my terminal here. So before installing or creating our application, we need to have certain things installed on your machine. You need to have Homebrew, which is a package manager that is going to allow you to install some of the tools. You need to have Xcode. You need to download it from the App Store. You open it, you accept all the terms, and you should be good to go. You need to have a Node.js installation. So I recommend that you use Volta, which is a tool manager. It just allows you to have different installations of Node.js on a single machine. And once you install it, you have Volta install Node 15 or whatever version you want. I had a little bit of troubles with Volta because I'm using a new Mac. So I'm using NVM, which is a different manager. But you can use whatever you want. As long as you have a working Node.js installation, it's fine. You also need to have Ruby installed. By default, it comes with all Macs. If you have any type of problem, you can just run brew install Ruby after you have installed Homebrew, and it will try to reinstall it for you. And finally, you also need a code editor. So I'm using VS Code, but anything you want as well works fine. So we need to have certain package managers. One's going to be for the JavaScript side of things, and one's going to be for the native dependencies. So Yarn is the package manager that we will use for our JavaScript dependencies. If you're using Volta, you can just install it with Volta, install Yarn. If not, you can just install it with npm-g yarn. This is going to do a global installation on your machine. I already have it installed, so it's there. You also need CocoaPods, which is a package manager for the native dependencies. So you can install it via sudo gem install CocoaPods. I already have it on my machine, so I'm not running all of the commands. Everything is kind of set up, but you should just follow the instructions on the lesson. Good. So now that we have all the tooling necessary, we can actually create a project. So I'm just going to take the command that I put in the console or in the lesson and paste it on my console. So I just need to replace the project name. I'm just going to go for something simple, building apps. And here you will notice that I set a specific version. So at the time of now, when I wrote the course, this is the latest version. And it's important that the React Native version and the macOS version match, right? Because otherwise you might have some issues in there. But I think the init template also kind of does some recognition. But just in case, if you see anything that's not working, that could be the problem. So this is right now installing. We're gonna give it a little bit. So this is the bare React Native project. Still cannot run on macOS, so we need to run a couple more things. So I'm just gonna cd into the directory that was created for me, and I'm gonna execute the React Native macOS init command. So this is gonna prepare the project to run in macOS. We're also gonna give it a little bit of time. So after that's done, our project is finally ready to run on macOS. So we will just use the command npx react native run macOS. So a new window will pop up in a little bit. That's the packager, that's Metro. So that takes care of taking our JavaScript or TypeScript and it kind of compiles it and makes sure everything is working properly in the simulator or in the mobile device, because JavaScript needs to be compressed and a lot of things need to work on different JavaScript engines. So don't close that window. If you close it, your application will just stop working. But you will see we kind of need to wait a little bit because this is all the native code that gets compiled. So let's just give it a little bit. So hopefully, if everything went all right, you should now have a small window with a brand new application, which is our app. It's really cool. So I'm just gonna open the project on Visual Studio Code. I'm just gonna do it from the terminal, but there are many ways to do this. And I'm just gonna go into the app.js file, and I'm just gonna change some text a little bit just to make sure that everything is working right. So where it says edit blah blah blah, I'm just gonna change hello world, and that's it. You will see that on the packager it compile our index.js file. So every time we make any changes, Metro just repackages our JavaScript and sends us back to the application, which is really cool. So we're gonna go a step further here. The idea is that we're not just gonna start coding, but actually provide you with all of the tools that you would use in a real world project. So we're just gonna add some extra commands that are gonna make the life easier down the road. So we need to go to the package.json file, and here I will just copy and paste it. We added 3 commands. The macOS command, which is just shortcut to start the app. The macOS :install command that will install all the native dependencies for us. And the nuke command. So sometimes things might get a little bit weird. They might get a little bit broken. So what you want to do is just clear the cache, clear all the dependencies, and just kind of start again. That should fix a lot of problems. So we're just going to make a shorthand for it in case something happens. So if I need to call any of these commands, I can just go into the terminal and I can just say yarn macOS, for example. Sorry, let me save it. And it's just going to run that command. So just a nice way to do certain things. So another thing that we're going to add into our project is TypeScript. TypeScript is JavaScript with types. It gets a little bit more complex than that, but it not only gives us types, it gives us autocompletion and code navigation and a lot of good stuff. So it's just a very sensible choice for your application, especially as it grows. It's going to help you a lot. So in order to install TypeScript, we're going to create a new file in the root folder of our project. We're going to call it tsconfig.json. And I'm just going to take the configuration that I put on the lesson. Just going to copy that and I'm going to paste it. So you can see there's a lot of options in here. I kind of set up everything for you already, so you can just use it. But you can actually configure how the language behaves quite a bit. Great. So now that we have TypeScript configured, we can actually start creating some TypeScript code. So in order to do this, I'm going to go to the root folder and I'm going to create a new folder in there. It's going to be called CRC for source. Inside of it, I'm going to create a new app.tsx file. So I'm just going to take the code that I put in the lesson, copy it, paste it. So you can see it's just a simple component. We'll go over components in a little bit. Don't worry about it. But you will see that your editor might complain about this. It says it doesn't know what React is. It doesn't know what React Native is. So this is TypeScript complaining about this stuff. So we're just going to go into the console. Let me just clear this. And we're going to at this command. So we're gonna do yarn add --def types / react and types / react native. So what this is gonna do, it's gonna fetch the types for both React and React Native for TypeScript. So we get type completions and type safety on both of them. So now if we go back to our editor, that you'll see that both errors have disappeared. So I'm just gonna save this file. Next, I'm just gonna go into the index.js file. So this file is kind of the entry point of the application. So the native code is gonna call this file first in order to mount our application. I'm just gonna copy and paste again. Not much changes except the import of our app. So instead of importing app.js, I am now importing from the source app.tsx. So if I save this and I go back into our application, that you can see hello from TypeScript, which is what we wanted. And that's it. We're pretty much set to go. So on the next lessons, we will start with state management and then move to theming with Tailwind. But we now have a working application. Hi, welcome to the second module for course. In this lesson, we will actually start writing the code for our application, and we're going to start with state management. That's a little bit counterintuitive rather than starting with the user interface, because I think state management is easier if you separate it from React. That is, React comes with a certain way of dealing with state, but it kind of mixes state with the way the UI is rendered, so that makes it hard to reason about. So I'd rather start with that. So we're going to use MobX. MobX is a library based on the observer pattern. So here I am on the MobX website, and you can see this small graph. So basically on MobX you have certain events that trigger actions. Those actions update an observable state. The change in your state notifies the computed values, which recalculate themselves, and those trigger side effects like rendering or rerunning a function and other stuff. So basically the main piece of the puzzle are observables. An observable is nothing more than an abstraction around a basic value. So once you have a value, you wrap it into an observable, and that enables it for it to be observed by other objects and other functions. So if you're a native Swift developer, maybe you have worked with the combined framework, so it's the same idea. So MobX is traditionally used with classes. Here on the website you can see the first example that they give you is with a class, but we're gonna use factory functions. That's gonna make our life a little bit easier. So let's just set up our first piece of code, and then we will go over the properties a little bit more into detail. So I'm just gonna start setting up a root store. A root store, it's going to be the entry point for all of our state. So I'm just gonna go into our application, and on the source folder, I'm gonna create a new file. It's gonna be called store.tsx. I'm just gonna take the code in the lesson, and I'm just gonna paste it into this file. So let's just walk over it. First, I import a create UI store function, which is not there. We're gonna create it in a little bit, but it again follows the same pattern. This is a factory function for a specific store. Then I'm gonna declare iRootStore type, or an interface, which is gonna help the TypeScript compiler figure out all the types. The problem is that we cannot derive all the types from our small stores because they depend on the root store. And we cannot derive the type of the root store without creating the smaller stores. So it's kind of a recursive problem. So we're just gonna give the compiler a hand and just tell it, you know, this is our UI store, its return type is whatever this function declares. So we're just giving the compiler a hand here. Then we have our main function. This is where we're gonna create the instance itself of our root store. So here you can see it, we have the store. It's just an empty object for now. And we declare it as any because once we return it, the TypeScript compiler is gonna figure out on its own. So then we create a new property and we actually call our UI store and we pass our root store instance, right? So this is so that the smaller stores have access to all the global state or to the other stores, so they can call another function, they can talk to each other. And finally, we return the instance of the store. So we will also import a final instance. This is the one that we're gonna use on our main application. And we could have just created this on the module level without a function, but by putting this into a function, that makes it nicer for testing, right? If at some point we need to create an empty root store, we can just call this function and not worry about how the module has been loaded or any other stuff. So before moving on, let's just go back to the lesson a little bit and let's talk about computed properties and actions. So an observable is fairly straightforward. It's just a wrapper that around a simple object or a simple value which can be observed. But we haven't talked a lot about observers. So observers can be either computer properties or React components. Computer properties are just that, are properties that get computed, derived from observables. So in the JavaScript world and in MobX, they're just functions. So functions are observers of any observable used inside of them. This means whenever a function that uses an observable inside of it, whenever that observable changes, the function is gonna rerun itself. So here's a nice example in a completely different context of how this is supposed to work. And this was actually how MobX was created. So on Microsoft Excel, you have probably worked with it. You have cells with values, and on different cells, you can actually create some formulas which are dependent on other cells. So whenever I change any of the values that feed into this formula, this cell gets recalculated. So that was the base idea that inspired MobX. That's basically how it works. So the last part of the puzzle are actions. So the problem with observables in JavaScript is that things can get out of sync. You could be calculating some result based on the observables, and then the observable can change. So then your state is not consistent, right? The final value is not reflecting of the state. So that's what actions are. Actions just kind of prevent these race conditions and make sure that there's order to the operations, right? You update the observable, you calculate it. Until that calculation is finished, you cannot do anything else. Great. So that's the very high level overview of MobX. So let's now go into how to use the observables. MobX has a fairly simple API. The latest version has made it quite a lot simpler. So we're just going to use a single function. It's called makeOutObservable. So makeOutObservable takes an object and it's going to enhance all the properties in this object. So non-function properties, numbers, arrays, objects, etc., they're going to become observables. Getters, which are special JavaScript functions, they're going to become computed properties. And any other function is going to become an action. So now comes the time where we'll create our first MobX store, proper MobX store. So I'm just going to take this file, and back in our project, I'm going to create a new folder. I'm going to call it stores. Here I'm gonna create a UI store.ts file, and I'm just gonna paste it. Let me just quickly fix this import. Great. So we're still kind of missing a little bit of things. Namely, we need MobX and React bindings. So I'm just gonna go to the terminal. I'm just gonna do it inside of VS Code. And I'm gonna do yarn add MobX and MobX React Lite. So MobX is the library and MobX React Lite is the bindings for the React component. Great, so let's just go over the store a little bit. So first we're gonna import the makeAutoObservable function from MobX. Then we're gonna import our type from our root store. And we can finally create the main function for our store. So it's gonna take an instance of the root store, which is gonna make it so that this store will be able to access any future stores. Inside of it, we will create the instance of the store itself by calling makeAutoObservable, and we pass an object to it. So this object has a books array inside of it. It's fairly simple, it's just title, and I created that string. So makeAutoObservable is gonna take this property and make it an observable property. Then we have a getUpperCaseBooks function. This is gonna be a computed property because inside of it we're using the books array. So we're just gonna take the books array and we're gonna map over it. That means we're gonna take each book and apply a function to it. We're gonna keep all the properties of the book, but the title, we're gonna uppercase it, right? And we just need to give the compiler a little bit of a hand here. And we need to declare the type of the returning function, which is just the same book array. The title is just gonna be uppercased. And finally, we have the addBook function, which is gonna take a title, and we're just gonna push inside of our book array a new book, which is just an object with a title and a new creation date. So if we go back to our store, we can see that the import error is gone because we have now our UI store created, and we can finally start connecting our React state or React UI to our stores. In order to do this, I'm gonna add just a little bit more variables into our root store. I'm just taking them from the lesson, and let me just fill the missing import. So these are context. It's a mechanism of React itself to share values. So I'm creating a context which is gonna hold our root store. A provider, we're gonna see in a little bit how that's used, and a hook, a function that we're gonna use inside of our components to take the root store from the context. So it's just a function, it doesn't take any parameters, and we just say use context, and we pass the store context that we created before. So I'm gonna go back into our app.tsx file, and I'm gonna take one more time from the lesson the code. Just gonna paste it in here. So basically the thing that has changed is that we're now importing a books component from a container. We're gonna talk more about containers afterwards, but this is just a React component. We're gonna create it in a little bit. Afterwards, I import my root store instance and my store provider from the store file I just created. Inside of it, the first thing, or the first component that I'm gonna use is the store provider. As a value, I'm gonna pass the instance of my root store. This already has it. If you take a look into when we declared it, we already passed it, but the types are declared like this. So I'm just gonna pass it again. Don't worry too much about it. And inside of it, I'm gonna use my books component, my books container. It's fairly simple for now. So let's just go and create our books container. So I'm gonna create a new folder in here. I'm gonna call it containers. Then I'm gonna create my books.container.tsx file. Once again, I'm just gonna take the code from the lesson. Right, so let's just go over it. First, I import React so I can use JSX. Then I'm gonna import the observer function. So this enhances React components to act like any other observer function. Whenever one of the observables inside of the component changes, the component is gonna re-render itself. Next, I import some React Native components. And finally, I import my useStore hook function from the store file. So my books component is just a functional component, and I enhance it by calling observer on it. Inside of it, I have my root store, which I get by calling the useStore function. And finally, I can return some UI components. So inside of it, you can see I access the root store. Inside of it, I access the UI store. And finally, I access the uppercase books. And finally, I map through them so I can display them in my UI. I take each book, put it inside a view. I need a key. This is just some React Native key that it needs to render our UI. Finally, a text component where I just show the book title. I have also added a button with a simple add button title, just so we can make sure everything is working. Inside of it is just a hard-coded function where I just call the add book action with a hard-coded value. So let me just save these two files. And now if we start our app, everything should be working. I'm just gonna do it inside of VS Code. You can do it inside of your terminal, whatever you want. And there you go. Our books from our UI store are displayed on our UI. And if I click on the add button, it should add more values. So before we move on with our application, there's one extra thing that we need to take care of. There are two problems with JavaScript itself. One of them is importing different modules. So you can see here we're importing our containers and our store using relative paths. So the problem is, as your application grows, as your project grows in complexity, whenever you want to move a file or a folder, it's a lot of work because you have to go into each file and rename all your imports. So we're gonna take care of that using a Babel plugin, which is gonna make all of our imports absolute. The second problem is just the importing of modules in general. Because JavaScript is evaluated at runtime, that means sometimes you might get into situations where a module hasn't been completely initialized, but you're already importing it and you try to call it within another module. So you get these weird race conditions where things will crash because they just haven't been loaded into memory yet. So we're gonna solve most of those problems by using a specific folder structure. So let's just start resolving the first problem, which are the relative imports. So in order to do this, we need to take care of two aspects. One is TypeScript itself. We need to give it some hints of how it should solve an absolute import. And we also need to do it on the JavaScript level. We need to do it on Babel. Babel is one of the tools that takes care of your JavaScript and compiling it for the device. So if you have used the TypeScript configuration I have given in the course, I have already set a base URL property for you on the TypeScript file. So this tells TypeScript whenever it sees an import that doesn't have a relative path, it's just gonna append this one, this path. So it's gonna solve everything from the root of our source folder. So once that's taken care of, now we need to take care of Babel. So in order to do this, we need to install one more dependency into our project, which is Babel plugin module resolver. So from your terminal, you can just do yarn at dev Babel plugin module resolver. That's gonna download the dependency, and once that's installed, we can go into babel.config.js, and I'm just gonna take it from the lesson one more time. Below the presets line, you're gonna insert the plugins. So this is just adding the plugin into Babel, very similar to TypeScript. So we're telling the root of our project is the source folder. So whatever path doesn't have the dot at the beginning, this is gonna append it to it. And then we just pass all the extensions that we want it to resolve for us. And that's it. So right now I could go into our app.tsx file and just delete this path. And if I save it, our application should still work just fine. I can right click and reload it. There might be a problem if you're running this for the very first time. That is that the plugin maybe isn't loaded into the Metro packager yet. So if you get some sort of error, what you can do is you just quit the app and you also close the Metro packager. And then we need to clear the caches of Metro. For that, we can just use the command that we used before that we created into our package, which is the nuke command. So this is going to take care of deleting all the caches, all the temporary files from our JavaScript compilation. And then we can just start it again. So I'm just going to quit this and just run the macOS command one more time, just so the application gets compiled again and everything starts new. So it's working. We just started the application again, and now we can start deleting the relative paths and just use the absolute paths, and our application should still work just fine. So that takes care of our first problem, which are the relative imports. But we still need to do something about the import order to prevent that some modules might not be initialized on time. So in order to do this, we're gonna follow one pattern. So inside of our containers folder, I'm gonna create a index.ts file. And inside of this index.ts file, I'm gonna export everything from my books container, right? So I'm gonna create this index file for most of my folders. Whenever there might be some dependency that I need to worry about, this allows me, for example, if let's just say as my application grows over time and I have more stores, for example, I can change the order how things are loaded, right? So instead of loading the UI store first, I can just move it down, and let's say I need to load my API store, for example, right? Or the API store, firstly, it needs for something else to be initialized. So I don't know, let's say a nodes store or something like that. So this kind of gives me a more explicit way to control how my modules are being loaded. So right now I only have 2 index files, one for the stores, one for the containers. So I can go back into my app.tsx file, and instead of importing directly the file, I can import it directly from my containers. So this TypeScript and JavaScript are smart enough to know that if you're pointing to a folder, then it should look for the index.ts file, and it just resolves the import for you. So if we go back into our application, everything's still working. In the beginning of the course, we mentioned we're not going to go into every little detail that we need to create a full-fledged React Native app, but there are some important topics that we need to cover. One of them is connecting to a backend, which most applications do nowadays, and we also need to fetch some data from said backend via network requests. So in order to do this, I have created a small server implementation. It's just mocked, it doesn't have any persistence, so you can kill it. There's no problem with it. So you go into the lesson and you can download it from there. I already have it on my downloads folder, so I'm just gonna decompress that one. I'm gonna move it to my developer folder. And let's just explore what this server can do. So on my terminal, I'm just gonna open a new terminal. And then I'm gonna go into the server folder. Inside of this, I'm gonna do yarn to install the dependencies, and I'm gonna do yarn start to start the server. So you can see it's running on localhost 3000. I'm gonna open a new tab, and I'm gonna use curl to do one request. I'm gonna do it on the book endpoint. So you can see it returns some data, and it's pretty much the same data that we have on our application. So this is the endpoint that we will use to query for our books for the data or for application. There's one more endpoint, so I'm just gonna take again the command from the lesson. So what this is gonna do is gonna do a HTTP post request. So here you can see -x changes the method of the command. -h sets a header, so we need to tell it this is a JSON, and -d sets the body of our request. So this is just a sample payload, this is just JSON. We send the title, and we send the date, and finally we have to set the URL where we want to send this request. It's also book. The endpoint hasn't changed, but because the method has changed, this is going to trigger a different response from the server. So if we send this, we can see it has returned some data. It has all the previous titles that were in there, but it has now inserted our newest value, which is the test. So the idea that we will follow is we're gonna create a layer only for the networking code. The idea is that none of the networking code should escape this layer. We're gonna put it into a store, just because if we do that, it's gonna get a little bit confusing, right? Sometimes you will be dealing with HTTP headers or some HTTP type of error, and you just want to keep somewhere everything encapsulated. So let's say one day you decide to switch to GraphQL, which is a different networking protocol. So instead of going into every single piece of your code where you need to change the networking layer, you can just go into one single store and change it there. So there's another important point that I should mention. So there are now several React libraries that they attempt to abstract a lot of the networking code for you. One of them is SWR from Vercel and React Query. So basically they follow the hook pattern on React, where inside of your component you just declare the route where you want to fetch, and it kind of takes care of a lot of the complexity for you. However, again, we're going to postpone using hooks for a little bit, and I just want you to get the basics, understand the basics on your own, and then you can decide maybe these libraries are a good decision for you and your project, but if not, you can do it manually. One more other thing that I should mention, our networking implementation will be quite simple, but you could enhance it with MobX, right? You could create more observables to say render some spinning wheels or block your UI while your network or you're fetching data from the network. So we're not going to do that, but it's perfectly doable. So now that we have our mock server running, now is the time for us to add the networking code to our application. By default, React Native comes with the fetch interface, which allows you to do network requests, but we're not going to use it because its API, it's a little bit awkward. So we're going to go with a better alternative. It's called Axios. It's just a different networking library. So we're going to start by adding Axios to our dependencies. So on your console, you just do yarn add Axios. That's going to fetch it. And now we're going to create an API store. I'm just going to take the code on the lesson and I'm going to create it on the stores folder. So let's just go over the code. First of all, I import Axios. Then I'm going to import the root type from my store. It's very similar to what we did with the UI store. Then we have the main function of the store, which is create API store. Again, it takes the root store instance as a parameter. And inside of the body, we have our store proper with two properties. One is the fetch books and another is the add book. So fetch books is going to do whatever its name says. It's going to fetch the books. So it's an async function. There's a link on the lesson if you need to read a little bit more about async functions. But basically, because the server can take a little bit of time to respond, we have to wait, right? So we have to give the JavaScript thread back so it can do update our UI and all the other stuff while we wait for the server to return the response. So that's why we have marked the function as async. And inside of it, we have a response object, which we're going to tell it to await for the server to respond. And we have Axios. We tell Axios to get our previous endpoint. We already explored it, right? This is going to return the array of books. And lastly, I'm going to return the data property. This is just where Axios puts the body of the response. And we're going to use that from our component. The add book is a little bit similar. This time it's going to take a title, which is a string. And this time I have also surrounded the networking code with a try and catch, just as an example, right? So something might go wrong. The title might be empty, the server might encounter some sort of error. So what you want to do to catch all the errors is wrap all your networking calls inside of a try catch. Again, it's fairly similar. We just tell Axios to do a post request. We pass the URL and we pass the body that we want to send to our backend, and we tell it to await. Afterwards, we just return the body of what our server has returned. So I am going to add the export from our API store so we can access it from different parts of our code. And I am also going to go into my root store and I'm going to actually create the instance of an API store. So I already modified the import before. Now I'm just going to add it, add the create API store to it. I'm going to add a new property to the type. I'm going to say this is the return type of the create function. And on my store proper, now it's the time to create the instance. So That's all it takes for me to add one more store instance into our root store, right? So let me just check the lesson quickly to see how we're doing. I have my root store. Okay, so now is the time to move to our UI store. So let me just take this code and I'm going to go into our UI store. So before, our UI store used to be the central repository for the book of data. Now our UI store is gonna reflect what we have on the backend. So every time we want to add a book, we'll call the UI store, but the UI store inside of it is gonna call the server either to fetch the data or to add more data, and it's just gonna be sort of this semi-synchronized state with our server. So I just copied and pasted the entire thing and we're gonna go over it. So the first change you will see is that I have created a new interface which I called iBook, and it's just gonna reflect the type of the book. It has a title which is a string, and it has a created at which is also a string. So inside of our store, a few things have changed. Now our books array, it's gonna be initialized as an empty array. That's when our application starts, but we're gonna help the compiler a little bit, right? And we're gonna tell it this, even though this is an empty array, it's gonna be filled with books. Next, we have our get uppercase books function. That hasn't changed at all, that's still the same. Whatever is on the books is gonna be uppercased. The titles are gonna be uppercased. So now I have changed the add books function. So the add books function is still gonna take a title, but here we see how we can communicate between stores, right? So this time I have marked this as async because again, we need to wait for the response from the server. So whenever I want to add a book, now I'm gonna go into my root store, into my API store, and I'm gonna call the add book function with the title that I get passed. And I need to await that response. Once I have that response, I will just check, if everything's all right, if the server has returned some data, and if it has returned some data, then I'm gonna put it into my books array. Now you will see this run in action function. This comes from MobX. The problem is that because JavaScript is single-threaded, when we do an await, when we deal with promises, which are a different JavaScript construct, inside of it, this is just a promise. So whenever we await for a promise, the JavaScript thread kind of loses the context, right? So even though this looks like a single chunk of code, after the await, something else might have changed, right? In our store with our observables and everything. So the state might be unsynchronized. So that's where running action comes. So let's go back a little bit and think our add book function has been marked as an action with make auto observable. But since we awaited, all the code that is after the await is no longer guaranteed to run in a safe manner, right? In a way that your state is going to be updated correctly. So that's what running action does. It kind of creates this tiny action inside any function. So I'm just going to pass a function to it. And inside of the function, I'm just going to update my books as if nothing had happened, right? So it's just an action within an action that might have lost the guarantees to make sure that the state can be correctly updated. Then I also added a fetch books function, which again just kind of calls the API store fetch books and just stores whatever the server returns inside of it. So here you can see in practice what I mentioned before, which is that all the networking code remains within a single layer, which for us is our API store, right? Here I don't see any HTTP codes. I don't worry too much about how the URLs look like, right? If I someday decide to change it, like I'm not gonna use HTTP pure REST responses anymore, I'm just gonna use GraphQL, all I have to change is this layer. So let me just go ahead and save that. So going back to the course, here you can see we talked about running in action, and now the time has come for us to connect our UI. So I'm just gonna take this code and let's go over it. So I'm just gonna take the code from the lesson, gonna paste it, and let's go over it very quickly. So we have changed a couple of things in the body of our function. Here is our first encounter with hooks. Hooks are the integrated way in React of how to handle state. So there's a bunch of hooks. We're not gonna go over all of them because it's just way too many and they're fairly complex. So we're just gonna use two hooks right now. One is the useState hook and the useEffect hook. So the useState hook, like its name says, it's meant to hold a piece of state. Right now we're passing an empty string and it's gonna return an array with two values. The first value is the variable itself, which right now has an empty string. And the second value is a function, which is gonna allow us to update the value, right? So as our components render, we can just call setTitle, pass it a new value, and on the next render cycle, this title value, which is on the first position, is gonna change. Next, we have our useEffect hook. So useEffect takes two values. The first value is a function, and the second value is an array of parameters. So in our case, our second value is an empty array. That is because we don't have anything to react to, right? So basically what this is gonna do with an empty array is just gonna run once. Whenever our component has finished mounting for the first time, useEffect is just gonna run the function inside of it. So in our case, we're just telling it to fetch the books, right? So this entire logic that we had on our UI store is gonna call to our API store. It's gonna store the books inside of it. Basically, this is just gonna run once our books container mounts. Inside of the actual UI code, not much has changed in how we render the books, right? We're still accessing the uppercase books, but we have added a text input, right? So the user or us, we can add some text in there. The value is gonna be the title, which is gonna be returned by our useState function. And we have an onChangeText function, right? So whenever the text inside of this text input changes, we're gonna pass it the setTitle function, and this is gonna set it as a state. And finally, on our button, we have changed the onPress function. So we're now calling the addBook function, but with the title itself, right? So the user types something, we update the local state. Whenever the button is pressed, we send it to our server. It's fairly straightforward. So if I save this now and I go into our application, you will see, well, right now the text input is invisible because we haven't applied any style into it, but I can just type something, right? So let's just say my favorite book. This is something that I want to add. I press the button and it's added there. So if I reload the application now, you will see that it's there. So for some reason it's twice in there. Maybe I clicked twice, but it doesn't matter. So the thing is that this is now saved on the server, right? So I can just go what's another book? Neuromancer or something like that. Doesn't really matter, right? And I can reload it again and it's there, right? So the server is taking no requests, it's saving the data. Right now it's mocked. And whenever our application mounts and this component, a specific mount, is going to fetch the books from our server. So let's just talk a little bit about hooks. Now is the right time. And you might be wondering, well, we can save state within the component and we can kind of observe things, right? This is basically an observer. Why did we use MobX? Why did we go through the trouble of setting up MobX? The problem is that as your application grows, using just hooks becomes quite complex, right? So if I just have to pass a title into a child component, that's fine, right? But as you go having more state within your component, as you go having more use effects into your component, it gets really hard to reason about all this stuff because anything can change, anything can cause your component to re-render, right? So you might change this one and this in state might change another thing, right? So that will cause a re-render. So it's just really hard to reason about this. That's why I prefer to use MobX because it's disconnected from the UIs, disconnected from the render cycles. So it makes it a lot easier. My advice is you can use hooks, that's completely fine, but use them for the really local stuff, right? Like for example, on our case, on our books component, this is fairly small, right? The title and the set title function, nobody else knows about this, right? Because this is just on the text input that's being used in the same component. So for this kind of stuff, it's completely fine. Use effect as well. Right now we're just running a single use effect, right? Whenever the component mounts, this is the mechanism that we use to trigger some action. So for this kind of use cases, hooks are completely fine.